I'm excited to actually, record this, get it on the books. I'll be completely honest. I have a backlog of episodes that I have to edit, so I need to like sit down for a
Oh.
weekend and like just and I guess I don't really have to because really like the editing is just very minor, just taking out a lot of the
Mhm.
filler words, the ums and the ahs, and I don't really do them all because sometimes it breaks up the flow. But I like to polish it a little bit and then throw my little like lower thirds and graphics on the video that I put on YouTube.
Oh,
And
cool.
so now that I've gotten used to doing that and people sort of expect that from me, like I did a couple of videos where I didn't do that at all. And then I got feedback that, oh, you didn't
They're
throw in
like,
any.
"Gabe, what happened? You're
It was like
slacking." You're like,
basically, and
"Dang
I was
it."
just like, I'm just trying to take it easy. I was really just trying to like just get it out the door quickly. And I was like,
Yeah.
okay. So, but yeah, no, I'm definitely excited to, you know, officially talk to you.
Oh, well, thank you. Me too.
So yeah, it's always interesting to just talk to. I'm very excited about this topic in particular because I think there's a lot of misunderstanding regarding robotics, automation, AI in general.
Mhm.
I mean,
Yeah.
any sort of technology. Like I've had conversations with people, and I think you and I spoke about this. We briefly touched on this when we were meeting. People seem to think that number one, it's going to take your job,
Oh my
and
gosh, yes.
and I'm like, I just I don't I don't have the skill set or the knowledge base to make the argument against that thought, that train of thought. So it's like so I try not to. I'm just like, just let it play out. That's usually my go-to. I'm like, just let it play out. Something's going to happen. The world will fix itself somehow. And I know that that's not valid for everything, but it's interesting. It's just interesting because I've had these conversations and you know Expedia and all these, they did away with travel agencies. Now you don't go to a travel agency anymore. And I'm like, well, do you know people that have worked at travel agencies? Like, yeah, well, what are they doing? They're doing other things. I'm like, it's like
So,
they're doing other things. Something worked out. It's like you have to adapt, you have to evolve at some point. And maybe it's not what you wanted to do. I never started doing what I wanted to do. It's like I just did something that I was good at and that I could provide for my family. And then I was like, well, I'll learn to like it because it's a paycheck. So
I was recently on a sales call, and it was actually this past Friday, and I started talking about robotics because usually I start talking about, T-slotted aluminum, and because that's like the structural framing and support. And then I start talking about like, oh, did you know you can use the structural aluminum as a fixture onto which you can mount sensors? And did you know that you can also use it to put your cabling inside to make it, a little bit more streamlined and smoother and safer? So usually the conversation I always start off with is the safety framing and guarding conversation. And then I say, oh, by the way, if you're interested in learning more about robotics, Neff Power's got this robotics laboratory and we can help you learn how to implement a new robotics application on site. And that was when someone said, oh, now hold on a second. Robots are taking our jobs. And it was just so confrontational. And I mean, I don't really enjoy the confrontational sales call, when everybody's like bristling and they don't want your solution. I had to take a moment and be like, okay, well, it's not necessarily taking jobs, but it is replacing tasks.
yeah,
So if you want to learn how to be incredibly valuable, if you want to be 4 times as valuable to your company, you could learn how to scale a task and then apply it to the entire industrial floor. Nobody really responded after that. So
you know,
I don't know if it was what they wanted to hear.
the irony is, here's the irony. Here's the thing about people working, and I wasn't alive back then, but I'm imagining the same conversations because conversations amongst the workforce seems to never really evolve past certain things. They're upset about working too much, getting paid too little, things taking too long. I wish things could be faster. I wish this wasn't so manual. I'm like, hmm. I'm like, certain conversations are repetitive. They keep coming up. It's
Yeah.
like, oh, deja vu. So even though I wasn't around back when the first factory was built, I just imagine these conversations happening. I'm imagining the conversations of whenever I worked somewhere, when I started working somewhere. It's like, man, I wish there was a faster way to do this. I wish there was a better way to do this. I wish I had more time to focus on doing something that I enjoy versus doing these manual things. See where I'm going, people? And
Right.
it's like,
It's because you didn't want to use your body as a tool. And the
Correct.
human body's not meant to be a tool. And we're meant to
Exactly.
use tools. We're not meant to become the tools. And I think a lot of people who are in manufacturing and who experience that entire, you know, um, the pushback, they're the ones who are rejecting this new tool,
Yeah.
which is robotics, because they see it as replacing them as a tool. And if they're able to level their own skill set up and to become robotics champions within their own facility, oh my
Mhm.
gosh, then, they're not using their bodies as tools anymore. They're
Yeah.
actually scaling, like you said, scaling and becoming more efficient.
Yeah, I mean, everybody at the end of the day wants to be more efficient in everything they do. They want to have, whether it's more time to themselves so that they could focus on doing something that they enjoy, maybe a passion project or a passion project at work. Um,
That's what this is.
exactly. And
Yeah.
they, but then it's like, oh, well, I would do it, but I have to go turn that lever 400 times or whatever.
A lot of times that's what it is because it's repetition. It's doing the same thing over and over again. That's what a robot's perfect for, is that
Yeah.
repetition on the human joint.
So, and then, so therein lies the irony. We don't
Mhm.
want to do it. We complain about doing it, but the moment that a tool, a s- machine, and in that, a machine with not a sentient being is presented to us that can do this, it's like, oh, they're taking our jobs away. So it's a funny conversation. And with that, ladies and gentlemen, this is the Mocha Bar Show. So we started before we started, but I'll maybe include a little bit of that in the thing. With me, I have Ginny Foster, who is the market development manager for Neff Power, excuse me. And we're going to talk, in case you haven't been able to tell, robotics, automation, and basically how it benefits humanity as a whole. And it is not going to destroy us, kill us, take over our lives, replace us, every other euphemism, metaphor that has been thrown out there in the world. So, Ginny, hi. Thank you for
Hi.
joining me.
Thank you so much for having me on your show, Gabe. This is a real
Absolutely.
pleasure to be here.
Well, thank you, thank you. So, in case if you heard, we were basically just riffing on some of the misgivings or misconceptions of robotics and automation in the workforce, which is, you know, tell us a little bit about Neff Power, what Neff Power does, and then we'll sort of continue from there and, how you can help people understand better.
Absolutely. So, Neff Power is an industrial automation distributor, and we are a robotics partner. And we're growing. We're located in the United States, and we're growing to cover more and more area across the United States every year. And we help our customers who are engineers and engineers in fabrication processes, engineers with factory production type of jobs. These are people who have highly technical skills and they want to learn how to become robotics champions. And we help them become robotics champions. We teach them how to use robots, and then we also help them deploy their robots for their first application, whether it's in our robotics lab or on site at their location.
So these companies that are coming to you, they've already made the decisions that robots is what they want, and they basically need your help in integrating it to their current infrastructure ecosystem so to make sure
Yes.
that they can efficiently get the most out of these robotics that they're installing. What typical businesses are the ones that are coming to you?
Usually these are manufacturers. So anybody who has a production process that comes at the end of that production process, there's a final result or a final product. So it's a technical process. It often involves conveyors. It can involve step one, step two, step three. We've helped people who started their process in a barrel, so they would have a barrel at stage one, and then depending upon what was inside, they would be filling the barrel with various levels of something, and then by the end, they would have a unique product unique to each barrel type. So we help our customers automate these processes. We help them, if they so choose, they can learn how to utilize robotics, and we help them become robotics champions.
That's excellent. And just to sort of like, I guess, further clarification, these manufacturing companies traditionally, how were they doing the manufacturing? Because, I guess part of like what we were previously talking about was robotics like replacing human beings, taking your job. At some point, I'm not going to be talking to you anymore. It's going to be a robot doing this podcast interview, and it's it's going to be a robot doing the interview, and it will probably sound a lot better than me. And it's just such a worrisome thing. But most of these companies were already invested in some sort of robotics, so it was no longer human beings doing the manufacturing manually to an extent. Not all of
It
them, but some
a
of them.
lot of them were doing manual,
Mm,
fabrication.
okay.
So many in my case, and this is probably not true for all different types of industries, but like food and beverage and automotive have been very automated. But then there's other industries that are not, and the ones that are really taking off right now, it's the pick and place, the palletizing, any kind of packing, like bin picking and placing, and then box packing and box palletizing. Those are the applications where we're seeing robotics just taking off exponentially. And they typically were not, they were not the industries that utilized robotics. 2020 was a really important year. And that's because not only because of the pandemic, but because it also marked the first year in which non-automotive robotic deployment actually exceeded automotive robotic deployment. So why is this important? It's because for the decades leading up to 2020, we only saw robots utilized in car manufacturing and in the automotive industry. So 2021 saw 39,708 robots deployed across the United States, and that was
Wow.
28% more than in 2020. So every year we are seeing exponential curves of growth within the United
Mhm.
States of the adoption of robots.
So basically, this is a not a trend because trends ebb and flow. This is the new standard. Companies,
Yes.
manufacturers of all types, they're going for robots for a lot of reasons. A, it's safer for humanity, or for human beings, period. You don't hopefully have as many injuries, thereby not as many deaths and, immediate deaths or deaths resulting from injuries, maybe long lasting injuries that really lower the quality of life.
It's because we're seeing the retirement of baby boomers. Every week, there's about 2,000 baby boomers that retire. And that's a huge body of knowledge that's just walking out the door. Bye.
Yeah.
Congratulations, bye. And in order to maintain that body of knowledge, like that know-how, the precision and the quality that goes with each person that walks out the door, the best way to maintain that is to automate it, because then you get consistency, you get quality, you get the same result again and again, and you don't have to worry about constantly training someone up only to lose them, because right now we have such high turnover rates, especially in places where there's manual labor. People don't want to stick around. I mean, can we blame them? It's not mind engaging, it's not fun. So the way to make something mind engaging and to make it fun is to create a skill set that you gain at the end of it, so that as you learn how to automate a process, by the end you can actually take that knowledge and then go deploy your robotic solution or your robotic application in the next process. It gives you a scalable skill set that employers want.
So, what does that do for me, the manufacturing guy that was there happily turning that lever 400 times a
Right.
day?
Well, I first
Well,
have to ask, if you were happily turning that lever, how's your elbow? How's your shoulder? Those have got to hurt. And wouldn't it
yeah,
be nice to have a chance to sit down and use your mind and think, just,
absolutely. No,
for a couple hours a day and
yeah,
learn
I'm with you.
something?
No, I'm
Yeah.
absolutely with you. I'm just, I guess I'm just trying to like think of the devil on the shoulder argument that comes from people that robots are taking our jobs, automation is bad for humanity, et cetera, et cetera, et cetera. But like we were saying before, humans weren't meant to be tools. We were meant to use tools. That was something that you so eloquently said. We can't have our cake and eat it too, because people are always going to want to be more efficient. Companies want their employees or the work to be more efficient so that they can produce more, get more. It's the saying, do more with less. It's a saying for a reason. It's a very valid saying. You have to wear many, many hats nowadays. Let's pivot a second. Let's talk about
Okay.
Yeah, because we can talk about that all day. So let's talk about industrial automation. You've said, the types of companies that are coming in, what they want to do. But now let's try to focus on how exactly Neff Power and robotics in itself can help these people. Let's say I come to you and I don't know what I want. I just know, hey, I want robotics to do my job easier. We're a food co-packer.
Right.
Um, what what do I do? Like, where do
Okay,
I
this
go?
is this is the fun part.
Yeah, like, how do I
Because
decide which robot I
yeah.
want?
Okay, so in manufacturing, there's two types of robots. There's industrial robots, which are the high speed, high velocity. They can move really quickly, but they also have pinch points. So these are the robots that require physical barriers and separation between the human and the robot. And usually a human has to stand on the other side of a safety fence. Like the safety fence I was talking about earlier, that's usually how the conversation starts. So somebody's like, hey, I need a safety fence in between myself and this operation that is intrinsically, well, it needs safety guarding because there's a risk involved. So you have industrial robots on one side and you have collaborative robots on the other. And collaborative, it means human collaborative. So these are robots and humans. They're working side by side in a safe way. And a person can literally walk up to a collaborative robot and hand it a work object, and the robot can continue performing its function without having to stop and then have a safety reset button pressed. So there is a trick, and this is where Neff Power brings value. The trick is this: with the right advanced machine safety devices, you can make an industrial robot behave like a collaborative robot. So you can still get that high speed, that high ROI with the ability to walk up and approach the robot and still interact with it without having to reset and press that safety stop button, which is a huge time saver.
So when I come to you saying that I want a robot and you tell me all this and I'm standing there like, huh? Um, like what's next? How do you I mean, I'm already bought in because I came to you. Like
Right.
I'm already bought in, so I know that I want it. But I guess maybe I have to play the tough business card and try to pretend to be stone faced and negotiate or something. But how do you get me over that hump? Because I
Okay.
guess what I'm trying to understand, while I may think I understand the benefits, I don't. It's because
Mhm.
let's say while I may think that I understand robotics, I'm very much just a curious person, and obviously I don't have your level of knowledge and understanding of how things work and integrate. And I'm just trying to think because I also want to be considerate of the people that are going to watch this and still have their naysayer opinion and not understand the holistic value of something like this in a company's greater good. There's people that work in companies, want their companies to succeed, and don't realize that in order to succeed, things need to be automated and things need to be roboticized. I don't know if that's a word, but I just use this, so maybe it is.
Okay,
um
so if to that I want to say if you're mass producing something and you're mass producing it and you have a quality control standard and you want to make sure that every time whatever it is that you are producing falls within that quality control standard and is acceptable and 99.9% of the time, that's where automation succeeds. If you're trying to make something by hand and like, make a hand knitted sweater that is, beautiful and crafty, I would say no. Let's not teach our robots how to do this because that's what humans do well. We create, we communicate like this on this podcast. We're
yeah.
communicating and we like to collaborate and problem solve together. That's what humans do really well. So for the things that are repetitive, for the things that are ergonomically challenging to the human body, and for the things that are, very dear to the bottom line, the ones you have to get right every single time, or else you waste the entire list of ingredients, those are the things that you need to automate. The catchphrase is usually dull, dangerous dear, and dirty. Those are the four. So those are the tasks that need to have automation in them in order for them to become better. I wanted to talk about your first question, I think, which was how do I know? Like here I come, I know I want robotics, but like what do I do next? Like now that I know I want a robot. And the first thing you want to do is to appoint somebody who will be the robotics champion at your company because you're about to purchase equipment that it's a capital investment on your part. you will need to have somebody who's responsible for it because it can't arrive and then sit in a corner. Because if people are afraid to touch it, if they're afraid to open the box, then it's really hard to get started. And chances are you're not going to be the one to open the box. So you've got to have somebody on your team who wants to open the box, who wants to be responsible, who wants to take charge and say, this is going to be my robot, and I will be the one to make sure that it is successfully deployed in application 1, 2, and 3. And so you have a clear timeline. You're like, okay, here we go. We're going to start with this one, and then we're going to move to the next one, and then move to the next one, and then we'll evaluate. You have to have somebody opening the box. The next piece I would say is make sure that that person, whether they're an engineer or not, they need to be talking to Neff Power engineers because we're the ones who can help you figure out, okay, now that you have your application and you know what you want to pick up, usually it's a pickup application. Usually that's number one. They want to pick something up, perform something, move it in space, and then put it down somewhere else. That's usually how these go. Not all the time, but usually. So we want to know, okay, what is it you're picking up? And then, all right, now that you're picking it up, what are you performing on it? What task, what process is happening to this thing you've just picked up? And then how do you want it oriented for the next part of the process so that the robot can deliver it to the final step and let go? And that helps us understand, okay, the payload, the reach, the type of end of arm tool. And then finally, once we know all of these things, oh, and cycle time, it helps us understand how quickly you want to do this. Finally, after we know all of these things, then we say, okay, now we can start making recommendations as to which robot is right for your application. Because to pick a robot first and then try to cookie cutter it into all of your different applications might not be a good idea. It might not work. You may find out that your first application, the payload, is greater than what the robot can actually pick up. And then you're going to be in a little bit of a pickle because you've got to return your robot and get another one that can actually pick it up. So it's better to always start off with the object and then work your way backwards. And that's what we want to help people do. We want to help you figure that first application out. And
Yeah.
that's what we have our robotics lab for. So you can
I
try it out.
mean, and that's generally a good rule of thumb for anything. You start backwards, like what's the goal? What's the desired end
Hmm.
result? And you work your way backwards from it. That's, sort of like project management basics that you get taught. Random question, because I am just really curious. What is the maximum load that a robot can pick up?
Oh my gosh. So the world-class company with whom we are partnered, they have robots that are very small that pick up anywhere from like 5 kilograms all the way to like multi-tons. And they specially designed this humongous robot to pick up, I don't know what make and model of vehicle it was, but it was a multi-ton vehicle. It was the end of I believe it was the end of body in white, and it would pick up the body in white and rotate it and then set it down in the next stage of the process and move on. So there is there's really not a limitation right now. There's so many different robots being developed right now
Yeah,
that I mean, even if you had a custom
it's crazy.
application, I'm sure you could get a robot to match what you need.
That is crazy. Now, you said earlier, traditional uses for most use cases are, pick up and put down, or picking up a load, putting it down somewhere, moving it. What other use cases are there potentially?
Oh, this one's going to be this is a polemic one. Welding,
Okay.
because there's a skill. The welder learns a skill. However, there are now robots that weld. So if you have a specific welding application that requires the same type of weld over and over again, repeatedly, there are robots for that.
Now, walk me through like the robot operation. Is there a human, somebody monitoring the robot
Oh my
to make
gosh. Okay. Are you talking about welding or are you just talking about like in general,
in
like
general?
in
I
general?
mean, in
Okay.
general, I mean, we can touch on welding, absolutely, but in general, I'm just trying to understand.
I get really excited about this because we have like videos on our Neff Power YouTube channel. We have videos of all this. So, say you have to have a human being monitoring your process, like coming in and out of the end of arm area, coming from behind the robot, entering from the side. Maybe you need to make sure that, there's a clean area so that something doesn't fall or there's no dust accumulation, so you have to come in and clean. We have a whole array of safety devices. These are safety laser scanners, area scanners, safety light curtains, so that you can literally quadrant off an area and make it so that the robot will experience what is called speed and separation monitoring, so that as a human being enters into each of these designated areas, into each zone, which
Mhm.
is closer and closer concentric radius to the robot will slow down its speed. And eventually, when the human being is within reach of the robot, it will come to a complete stop. And then as the
Oh,
human backs out again, the robot will increase its speed until finally the human is outside of the safety zone. And then the robot can operate at, full functional speed, whatever that may be.
so your robotics labs is in St. Louis? Because I kind of want to see this.
Yeah. We do have videos of it on our Neff Power YouTube channel. So
I know, but I
um,
want to experience it.
you
So I'm gonna
could
have to
come. Oh
take a
my God.
trip to St.
You want,
Louis.
do you want to come to St. Louis? I would.
I really do. I really want to see this. I
Okay.
really want to
Well,
see this in
please,
person.
then let's
I
set
was,
something up because I would love to do something in person with you.
yeah, I was like, because this that honestly, that just at the end of the day, I'm just a geek, and that just sounds really cool. I just want to see
It
it.
is really cool.
I
Yeah.
just that sounds awesome. So, what other applications are there? Because I'm just thinking, the welding, the picking up, but
Hmm.
there's really, at the end of the day, there's no limit to what it can do. It's just really just up to the imagination and the applications that are built or needed by the manufacturer.
Right. So this is kind of like mind blowing to somebody like me because I keep picturing the robot as with a pedestal and bolted to the floor. So it's
Mhm.
bolted to the horizontal surface at like 0. But what if you mounted it to the ceiling? Oh, we have customers who mount their robots to the ceiling. So they have conveyors that go underneath the robot, and the robot is literally using a 2D vision system to identify and then reach and grab the object that it's been taught to grab. So, you can have multiple sized objects, you can have multiple shaped objects, you can have a whole bunch of things that are, say final products. They're rolling down your conveyor, and your robot is just looking for nonconformities, and it's trained to pick up nonconformities and put them in the nonconformities box. We have customers that do that too. So, I mean, there's there's no limit to what it is. If you can imagine it and your hands can do it, then probably a robot can do it too. The trick is picking the right application so that you're
Mhm.
getting the maximum return on investment on your robot.
That's actually that sounds really cool, actually. No, I mean, it's just a lot of things. I'm trying to visualize it. So if I'm taking a little bit, because in my mind, I'm just trying to visualize everything and see it. And I'm gonna have to figure out a way to like include that in the video for this so that people can watch it as we're talking about it. That way they don't also get to see me looking stupid as I'm like thinking about what to say next. But no, I am fascinated. I'm fascinated by this. And I want so jumping back and forward in a couple questions. How do you test that the picking and loading to make sure that it's picking up the right object, number one, and how do you test the reactions to the humans to make sure that it's slowing down and coming to a complete stop when appropriate and not necessarily like smacking the
So,
and,
so
I'm
we,
just wondering, is there like a
Gabe,
test
oh
dummy?
my gosh, Gabe. So we just did a class in May. We brought my customer into our robotics lab and we did a class with them and they tried to like beat the system. They were like, if I run at the robot fast enough, then I will touch the robot before the robot stops. And they couldn't do it. It's because the functional safety unit it's tied in. It's the clock on that is like milliseconds fast. So there's
Oh man,
I mean, you're trying to race electricity, and
yeah,
it's hard for a physical human to do that.
we
Wait,
can't.
what was
It's not possible.
what was your other question? The question before that?
Oh, about the like, how does it discern? Like, I know you said it has a 2D vision system
Yes,
that it allows it to discern from the packages of what is a valid box or a
yes.
non-conforming box or whatever the parameters are set. How is
That's
that
that's deep
tested?
learning. Deep learning. So we actually have what is called a Plock 2D camera in our lab, and it's a localization. Is it like a part localizing? I'm gonna get the acronym wrong. It's PLOC 2D. you literally train it. You train it to recognize a plane, and then, within this two-dimensional plane, then you start introducing objects. It's up to you to choose the objects, right? So you get to
Mhm.
draw a trace around the object, and you say, okay, this object is correct. And then you say, camera, okay, this object is not correct because look, see this little line right here? It's broken. The line is all jaggedy, piece is cracked. So the camera will learn what a straight line is, it'll learn what a jaggedy line is, and then as it sees objects that reflect those characteristics, it will sort them for you. So you don't have to.
Nice.
It's an amazing piece of technology, and we also have a whole bunch of videos about that on our YouTube channel, and we have an expert who speaks to it much more eloquently than I do. I just get excited about it.
I'm with you. I would not be able to talk about this at all, so I'm with you on this. No, this is great. I am going to link to the YouTube channel.
Oh, fantastic.
So yeah, I absolutely will do that. Now, what is next? I mean, let's talk about like there's no limits to what robotics can do. Whether it's industrial automation, engineering. Well, I don't know. Have we talked about engineering? I don't think we've talked about engineering, did we? We haven't talked about
Mm-mm.
engineering. Let's talk about engineering. Um,
Okay.
let's you know from an engineering perspective, whether it's, let's say the Army Corps of Engineers needs, robots to help build a bridge. And I just picked the Army Corps of Engineers because I was watching the news yesterday and I saw something. But let's say they need help building a bridge somewhere or something. Can robotics potentially help with this? Like what are the applications in terms of engineering, whether civil, mechanical, electrical? What are the applications for robotics? And I probably phrased that question really badly because I don't truly understand it. So,
Okay. So the engineering is like everything that's problem solving, right?
mhm,
So within the world of problem solving, you've got the people who are designing the robots,
mhm.
and then you've got the people who are learning how to deploy the robots. So, I mean, with design, like that's where it's limitless. The only thing that's limiting our design are our own imaginations and our budget and the human beings involved, right? So with design, it could be you could go in any which direction. So you're specifically wondering, could robots build a bridge? And
In this specific, yeah, scenario, yeah.
I imagine they could. Where I see robotics going in the future, and I think this might be more applicable to, manufacturing and production facilities, that focus
Mhm,
area of engineering. I see forklifts as being the next frontier because truly, forklift technology, it's one of those technologies that, yes, it helps us pick up and carry very heavy things, but it's also the one that's the most risk prone. And if you were to look up the number of forklift accidents that happen every year, if you were to go to OSHA's website and just look it up, you would be astounded. It costs human lives, sometimes extreme injuries, and also the amount of property damage it's astronomical. We're talking about millions of dollars. And you can see videos online, which I don't recommend. I do not like watching those videos, but they are abundant. Forklifts, I think in the future, will be more self driving. So they'll have more self driving cameras. So they'll have that LiDAR, that three-dimensional camera
mhm,
technology. And they will also be equipped with the robotic armatures to help them actually load and unload their own pallets. I think for sure forklift technology in the future is it's not going to look like what we see it today. And there's a
yeah,
huge benefit. There's a huge benefit for everyone involved. To the forklift drivers who are feeling threatened by it, I think it's really worth understanding and knowing and learning about before you jump to the fear. And that's another thing I want to talk about too is
yeah,
that
let's go.
jumping into fear right away, because like that
Mhm,
that response that we have to new things, it doesn't have to be one of fear. And that's
yeah,
why I always recommend this book.
nice.
This is the
Let's
Mindset
go.
book by Carol Dweck, and it will literally spell out how to have a growth mindset and how not to have a fixed mindset, because the fixed mindset it's the ego-based mindset. It's the
Mhm,
one where the ego is afraid to learn because it will prove that the ego doesn't know enough, or it'll show that the learning experience is one in which the fixed mindset will fail because there's always a fear of failure. So all of the negative, all
Hmm.
of the negative responses I've ever gotten, I just truly hope that each and every one of you, whoever you may be, that you're not afraid to at least learn about it first before you respond.
Absolutely. And I think that is the perfect note to leave this on, because I what just to sort of add on that, so I guess we're not going to leave it there. Is, part of humanity, our humanity is evolving. This is something, for those that know me, I've said numerous times online. It's like we have to sort of evolve everything that we're doing, whether it's as peoples, as professionals, as spouses, sons, fathers, mothers, et cetera, et cetera. We're constantly in a state of evolution. We're constantly learning new things. 20 years ago, yeah, 20 years ago, I did not have a smartphone. I didn't have a phone, actually, period. But I mean, I had a house phone, but yeah, I didn't have a cell phone or whatever. And it's like I evolved to carrying a smartphone. I evolved to using the GPS instead of like driving around lost all the time. We're constantly evolving and learning about new things. I venture to say that 9 out of 10 people in the US have a smartphone of some sort. You learned to accept that. It's, and you're right. It is fear. It is fear of something new, fear of the unknown, or what they think they know. They think that they know what's going to happen. Arnold Schwarzenegger is going to come riding a motorcycle and throw on some shades. It's No, it's just, certain things need to be embraced. It's for the betterment of humanity. Think about it. Do we want our children to be breaking their backs doing manual labor the way that, our parents didn't want that for us? We don't want that for our children, et cetera, et cetera. So it's
I
about
was
wanting
just
better.
Yeah, I saw my niece and nephew were watching a cartoon, and I forget what the cartoon was, and it was dogs, but it wasn't Paw Patrol because I can recognize those. It was a different set of dogs, and they were working in a factory and they were sorting frisbees, but they were sorting frisbees by hand, and I was like, oh my god, I can't believe this is on a children's cartoon, because what was happening is the new dog couldn't figure out how to sort the yellow frisbees fast enough, and it caused a huge pile up, and then he had to like hit the safety stop button, and then the number of days without incident went down to 0, and they were all disappointed in him, and I was like, well, they shouldn't just be disappointed. That was like a safety incident. So thankfully none of the cartoon dogs got hurt. But I'm like, this is like a perfect example of, how we could show like there's another set of tools, and it does start with a smartphone. Because Gabe, if you know how to use your smartphone, you know how to operate a robot. Because there's a Smart Series robot that utilizes a tablet. It's called a Smart Pendant. It looks just like, a regular tablet would, a smartphone would, and all you do is interact with it by pressing the buttons on the tablet. So you can
Yeah,
you can use it to tip, you can use it to like rock the robot back and forth to get the right angle. You can use it to drop and pick up and grasp. The
yeah.
whole thing is operated on a tablet. So,
I mean,
it's just another tool.
it really is. I think humans, we need to stop being so afraid of new things. And I don't know if it's other cultures, 'cause I've noticed this a lot. And, because I noticed that other cultures, whether in Japan, that I've been to several times, or in Europe, they're very quick to adapt or adopt, excuse me, new technologies. So I don't know if it's an American, like something that's embedded in us, that we're afraid of new things for some reason.
We have that good
And
healthy bell curve, right?
and it's
Like
yeah,
there's the early adopters over here, and then there's like everybody else up here, and then there's
yeah.
finally
And I'm like, so I don't like, I'm always wondering, because I'm fascinated by that. Whereas, the US is ahead of most of the world in a lot of other ways, when it comes to certain things, technology, phones, etc. Other countries are like far ahead of us, and it always fascinates me as to why that is. And it really is sort of a mental block, a fear of new
it's a
things.
fear and the of the unknown, and it's
Correct.
a fear of being wrong, I guess, you
Yeah.
know?
Yeah,
Because like,
absolutely.
and I think that starts in schools. And this the oh this is a good book because it'll get into this. It'll start, it talks about how in schools, if you have constant reward for always being right, and you're
Mhm.
always the smart one, what happens when you're
When you're
not right?
wrong.
Oh my God, you're not the
That's why
smart one anymore.
I think it's so important for people to fail at some
Yeah.
point in their lives, preferably early, not
Hmm.
too bad, but preferably early so you can know that, hey, you don't always win. Not everybody gets a trophy. I mean, if you deserve the trophy, get the trophy. Absolutely. But there's like not everybody gets the trophy. Sometimes you have to work harder. Like, how do you know you need to work harder if you're being rewarded?
Yeah. You would have no
So
way of knowing that.
you do need to know it's a feedback mechanism. You fail. Failure is a feedback mechanism. You fail. Oh crap! I need to try better so I don't fail next time.
Hmm.
Um, and I think that's something that we need to be more mindful of. It's not necessarily being wrong, being afraid. Fear is a great motivator to help you to succeed. There's nothing wrong with being afraid of something. So it's just, understanding that fear, not letting it control
Yeah.
you. But, there's nothing wrong with, I think a healthy, a little fear is healthy, in my opinion, to help you to sort of move on, motivate you, like that fire under your butt, so to speak, and, get you moving forward. Otherwise you're just going to be standing still forever.
I think taking the moment to pause and to really understand what it is you're feeling, and
Hmm.
then really figure out like, well, why would you be feeling that? I
Yeah.
think that helps too. And it takes a lot of reflection time. You don't realize how much time is necessary in order to reflect until like you have this aha moment and you look at the clock and you're like, "Oh my God, hours have passed and it took me that long to figure it out."
Without fail, always. Mm. Well, Jenny, thank you so much. Where can people find you? I'm going to put everything in the show notes, but go
Oh,
ahead and
thank
tell
you.
people where they can find you if they want to reach you, reach Neff
Absolutely.
Power and just learn more, or maybe they're interested in talking to you about robotics and getting it integrated into their manufacturing systems.
Well, I love connecting on LinkedIn. You can find me on LinkedIn with Ginny. It's a Ginny Foster, Foster. And you can also find Neff Power. We have a website and we also have a YouTube channel, and we're also on LinkedIn. And that's N as in Nancy, E as in Edward, F as in Frank, F as in Frank, Power.
And you can find me on their YouTube video because I am going to make a trip out to St. Louis and I want to see
I'm
that
so
robot
excited.
in person.
Yes, let's get it on the books. Let's schedule this.
I'm definitely want to do this. Thank you so much, Jenny. I can't wait for the people to
Yeah,
hear this
thank
one.
you, Gabe.
Did you know?